Hi everyone, welcome to the channel Math for me and you. Let's learn maths together. Hello, in this video we do practice on expressing different logarithmic terms as a single logarithm. For that, let's recall the laws of logarithm one by one. For this topic, that is expressing as a single logarithm, we use only 3 logarithmic laws, and they are: first one, log a times b times c to the base b is equal to log a, we are distributing logarithm to the first term a to the base b, plus log second term is b to the base b, plus log c to the base b. Log a to the base b plus log b to the base b plus log c to the base b. 3 terms on the right side with the same base. And when we start reading from right to left, we can see the left side log a times b times c. From here itself we understand how to write a single logarithm. From the 3 terms, we collect log with base b and write one time. After that, open a bracket. Write all other terms inside the bracket. That means here a, b and c. Write inside the bracket. But plus we have to change with the operation multiplication. That means when we write as a single logarithm, we have to change addition as multiplication. So instead of plus, we will write times. That means if we express logarithmic terms as a single logarithm, we have to change the operation addition to multiplication. With the help of an example, we can practice more about this. So here consider 2 logarithmic terms. First logarithmic term is log 2a to the base b, plus second term is log 3c to the base b. So you can see 2 logarithmic terms connected with the plus. We are going to write as a single logarithmic term. So start with log. We are connecting or writing as a single logarithm. So we can write first log. After that, open bracket. Log with what is the base? Same base b. Then open bracket. Write all other terms inside the bracket. The other terms are 2a and 3c. And we will connect with the operation times. Write 2a, then times 3c. So simplify this and you can see times we have put instead of addition. Then we write the result log to the base b, and inside the bracket 2 times 3 6 and a times c ac. So the corresponding single logarithmic expression is log 6ac to the base b. Second law is log a over b to the base b, over means division, is equal to log a to the base b minus log b to the base b. This means when we put logarithm to a over b, we get the result log a to the base b minus log b to the base b. When we read from right to left, log a minus log b is equal to log a over b, and everywhere same base b. That means minus. When we write as single logarithm, we have to change with division or over. So this is an important result to remember. If we express logarithmic terms as a single logarithm, we have to change subtraction, that means minus, with the operation division. Division means over. So we are going to practice this idea with the help of an example. For that, consider 2 logarithms separated with minus. Log 5pq to the base b minus log 10p square to the base b. You can see 2 logarithmic terms. We can write as a single log. So write log first. After that, open bracket and keep inside all other terms. So after log, then term is 5pq Then minus we have to change to divide. 5pq, divide means over. After log, the next term is 10p square. So it is 10p square as denominator because of division. Now simplify the bracket, we get the result. We can write log to the base b, and inside the bracket common numbers we can cancel. 5 cancel with the 10. 5 times 1 and 5 times 2. Also we can cancel p and p. Denominator is p square, so we cancel 1p from numerator and denominator. We get log q over 2p to the base b. Third law of logarithm. Log a power n to the base b is equal to n times log a to the base b. Left side log with a power number where n is the power, and right side we can see n is placed before logarithm. N has moved and it is placed before the logarithm. So when we start reading from right to left, n times log a. If any number in the beginning of a logarithm, we can place it as a power of that term. We can write log a power n. So this also we can understand more with the help of an example. If we see 2 log x to the base b. So there is a number 2 in the beginning of logarithm. Same like to the right side of the third law, we can place it the power of term x. So we can move 2 and keep it as the power number. Log x power 2 to the base b. That means we have moved 2 as the power of x. Then we get log x square to the base b. Consider a question. Express the following as a single logarithm. And here we can see 3 logarithmic terms. We have to express with one logarithm. Log 2x to the base b plus log 3y to the base b plus log z to the base b. We start with single logarithm, and remember when we express as a single logarithm, plus or addition, we have to change with the operation times multiplication. Then we are going to write with one logarithm, log to the base b. After that, open a bracket, collect all other terms, and the first term we write is 2x. The operation we connect is times instead of plus, times. Next is 3y. Again we connect with times. Next the term is z. Now we can simplify the bracket. We get log to the base b, write as single log. Then inside 2 times 3, 6. X times y times z, x, y, z. Log 6xyz to the base b. 3 logarithmic terms now we have expressed as a single logarithm. Second question. Here we can see 2 terms, logarithmic terms, and separated with the operation minus. Log 20a square c square minus log 5c power 3 with the base b. Both the terms with the base b. And if we see minus or subtraction, we change with the operation division. We can write as single logarithm, log to the base b. Open a bracket. Inside the bracket, write 20a square c square. Minus we change as over. Then write 5c power 3 as the denominator. Simplify the bracket, we get the single logarithmic expression. Log to the base b. 20 and 5 we can cancel. We get 5 times 1 and 5 times 4. 4 in the numerator. C power 2 numerator, C power 3 denominator. After cancelling, we get C in the denominator position, because C power 2 means it is C times C. And what is C power 3? It is denominator is c power 3, we can write as c times c times c. After cancelling, we get 1c in the denominator. So we can write 4a square numerator and only c denominator. Log 4a square over c to the base b. Next, 5 log 2m to the base b minus 3 log 3mn to the base b. You can see a number in the beginning, that is 5 in the first term, number 5 in the beginning. We can move to the power position. 5 we will move as the power of 2m. Also the second term, the number in the beginning is 3. We can do the same step. 3 we will move and keep it the power for 3mn. Then the expressions we can write log 2m the power 5 with the base b. 2m we keep in bracket because all with the power 5 to the base b, minus log 3mn. Also we keep 3mn in bracket and give the power 3 for all these terms to the base b. That means we have changed 5 and 3 as power numbers. Then we get log 2m to the power 5. So what is 2 power 5? Log, we have to simplify what is 2 power 5. And 2 power 5 means 2 repeats 5 times. 2 times 2 times 2 times 2 times 2. How much it is? 2 repeats 5 times. So 2 times 2 4 times 2 8, 16 times 2 32. 2 power 5 is 32. We can write there 32. M also with power 5. That means we can write m to the power 5. Next is minus. Second bracket we are going to simplify. There we can see 3mn to the power 3. 3 power 3. 3 times 3 times 3. That is 27. Then give the power for m and power for n. So we get m power 3 and n power 3. Now we can see two logarithmic expressions connect with the minus. So we are going to write as a single logarithmic term equal to log to the base b. Then 32m power 5, the first one. Minus means we write divide. 32m power 5 over 27m power 3 n power 3 m cube n cube. After simplification we get the single logarithmic expression. 32 and 27 we can see it has no common number, so we write same 32 over 27. Next, similar terms m power 5 over m power 3 equals m power 5 minus 3 m square and n power 3 right denominator. So we get log 32 m square over 27 n power 3 to the base b. Next one, 1 over 3 log 64 p power 3 q power 6 to the base b minus 1 over 2 log 49 p power 4 q square to the base b plus 2 log p q to the base b. 1 over 3 is the beginning number. It's a fraction. Whatever the number in the beginning, we will move and keep it as the power for the terms after logarithm. So here we will keep as the power for 64 p power 3 q power 6. Same thing for 1 over 2. 1 over 2 is the number. We will move as the power for 49 p power 4 q power 2. And 2 we keep the power for p q. Then we can write each term. The number in the beginning we will move as power. So write log to the base b 64 p power 3 q power 6 with the power 1 over 3. And the base is b minus log 49 p power 4 q power 2 with the power 1 over 2 to the base b plus log pq to the power 2 to the base b. When we give the power, keep the terms in bracket and give the power. Now simplify each bracket. Log to the base b. And here we can see 64, the first term, first number, gets the power 1 over 3. Then next is p power 3. Get the power 1 over 3. Already power 3, again with 1 over 3 means it is 3 times 1 over 3. P power 3 times 1 over 3. Q will get the power 6 times 1 over 3. Minus log to the base b. Here also we give the power separate. 49 to the power 1 over 2. P power 4. Again power means it is times 1 over 2. Q power 2. Again power means it is times 1 over 2. Q power 2 times 1 over 2. Plus log p square q square to the base b. Again simplifying. First term we get log to the base b, and now we are going to find the value of 64 power 1 over 3. 64 to the power 1 over 3. What is 64? 64 is 4 times 4 times 4. We can write 64 as 4 power 3. 4 repeats 3 times. So again, if we take the power 1 over 3 means 4 power 3 gets the power 1 over 3. If two powers comes together, we multiply the powers. 4 power 3 times 1 over 3. 3 and 3 cancel. So we get the result 4. 64 power 1 over 3, the value is 4. That means we can replace 64 power 1 over 3 with the number 4. We write here 4. P power 3 times 1 over 3. 3 and 3 cancel. So we get only P. Q power 6 times 1 over 3. So we get Q to the power 2 minus. Next is log with the base b. Here it is 49 power 1 over 2. What is 49? 49 means 7 times 7, or we can write 7 power 2. If we take the power 1 over 2 for 49, then it will be given for 7 power 2. Then what happens? 7 power 2 times 1 over 2. 2 and 1 over 2 cancel. We get the result 7. 49 power 1 over 2 is equal to 7. We can write in place of 49 to the power 1 over 2 as 7. P power 4 times 1 over 4 cancel. We get P power 2. 1 over 4 times 1 over 2. Then Q power 2 times Q power 1 over 2. It is Q. Plus log P square Q square, same we write to the base b. 3 terms, and first 2 terms connect with the minus and the last term connect with the plus. We are going to write a single logarithm. Log open bracket, after that 4pq square. Then we can see minus. Minus means divide, put over. So then write the term 7p square q as denominator. Next is plus log. Plus we will change to multiply. And then p square q square. Simplify the bracket. Similar terms we can cancel. So we get p square cancel with the p square. Also we can cancel 1q from numerator and denominator. The remaining log to the base b, and inside the bracket 4 over 7 because no common numbers. So we write 4 over 7. P and q power 2, q power 1 together we can write q to the power of 3. So we get the single logarithmic expression. Hope you understand what we have discussed here. If you like this video, please share with your friends and subscribe my channel. See you with more useful videos. Thank you.